Welcome to All This Math. This is Professor Parker, and today we're going to solve a quadratic inequality. Quadratic inequality. I like solving quadratic inequalities. I'm not even going to hold you. I like solving them because these are the type of problems that are not that difficult to do, but they do require some steps sometimes, and they kind of make you feel like you're smart when you're doing them. You know, you knock one of these out, you feel like you're on top of the world, right? So pay attention, take notes, and I'm going to show you how to knock these out. All right, so first thing, how do I know it's a quadratic? Because a lot of times, again, we throw terms around, teachers throw terms around, and we take for granted that the students are going to know what we're talking about. So when we talk about a quadratic, we know that this is a quadratic because the largest exponent you see is a 2, right? This little 2 right here, this is an exponent. This x has an exponent 2, but it's not written, so that means it's a 1. It's understood to be a 1. And this is a constant, so constants don't really play a part in determining whether something is a quadratic, a linear, a cubic, a quartic, etc., etc. So just know that when somebody says, oh, this quadratic this or this quadratic that, that means that the biggest exponent is a 2. All right, biggest exponent is a 2. All right, now, first step, we need to put this in standard form. This is not in standard form. Standard form means that all your terms are on the left side of the inequality sign, and you only have a 0 on the right. So what I'm going to do is I'm going to slide this x and this 6 over to the left, right? But I'm going to still have the terms in descending order according to degree, meaning this. My 2x squared has the biggest exponent out of all three of these terms. So I'm going to write the 2x squared first. The x is going to move over, so that's going to become minus x, because when it switches sides, the sign changes. Transposing this and moving it over is the same thing as me doing minus x and minus x on that side. I'm going to do the same thing with the 6. This is a positive 6 on the right side. When I move it over, it's going to become a negative 6. All right, so now this is a standard form. All right, so now watch me work. We need to factor this because what you want to do is we're going to have a number line. We're not going to do the whole XY plane and draw the actual parabola. We're not going to do that. But we're going to find the intervals that are solutions to this inequality. And we're going to use a number line for that. So we want to factor this. So our first step was to make sure it was in standard form. We did that. We got that out the way, right? Now we need to factor this to find out what the x-intercepts would be if we were to graph this on the xy plane, right? So this is a trinomial. All right, so I know I'm going to have, right? I'm going to have that. And what I'm going to do, I'm going to use the trial and error method. There's a couple different methods. We can use the grouping method, the factoring by grouping method. We stretch this out from 3 terms into 4 terms, and then factor by grouping. We could do that. Another method I really like called the swing method. I'm going to do a video about that, matter of fact, the swing method, pretty soon. But what I want to do is, let's just do trial and error, right? So we take the factors of 2, right, or 2x squared, put them into the binomials. So 2x and x, because 2x times x equals 2x squared. And then we want to take 2 factors of negative 6 that when we place them inside the parentheses will give us 2 binomials that when we do FOIL, we would end up with this expression. All right. So I got to, let me see. Let me think. 3 and 2, 1 and 6. I gotta think. So if I put a 6 right here, that's gonna give me 12. I don't want that. If I put a 1 right here, that's gonna give me 2, and I don't want that. If I put a 2 right here, okay, let's do this. Let's put a 2 right here and a 3 right there. All right. But then the question is, what are the signs gonna be? Because my outer terms, because remember FOIL, first outers, the O in FOIL stands for outers. So when I multiply 2x by 2, that's going to give me a 4x. And when I multiply 3 times x, that gives me a 3x. So I got 4x and 3x, right? So 4x and 3x. But I need these 2 terms to add up to a negative 1x. Negative 1x. See the invisible 1 right there? You don't need the 1 because it's a negative sign. Negative sign in front of the x means negative 1x. So in order for that to happen, I need negative 4x and a positive 3x. So the only way I can make a negative 4x is doing 2x times negative 2. So make that negative 2. And the only way I can make a positive 3x is if I do positive 3 times x. So put a plus sign right there. And that's the trial and error method. Like I was trying to visualize this, and I put a 6 right here, and in my head I did the math. I knew that wasn't going to work. I put a 1 right here and a 6 right there. I did the math. I knew that wasn't going to work. And I said, okay, well, 6 only has 2 other factors besides 6 and 1, 2 and 3. And then the question is just, well, where do I put the 2 at? Do I put it in this spot or do I put it in this spot? Where do I put the 3? Do I put it in this spot? Do I put it in this spot? And then you got to just kind of do the FOIL method and figure out what combination is going to give you this middle term right here. And we realize that negative 4x plus 3x is going to give me negative x. All right. So now what we do is we take each of these, right? And, or at least this is how I do it. I'm going to take each of these, 2x plus 3. I'm going to set them equal to 0, right? Each factor. Take each factor, set it equal to 0. And then I'm going to have x minus 2, which equals 0. And I'm going to solve. Now, I'm going to do this real quick because this is easier. Add 2 to the left, add 2 to the right. So we got x equals 2. Okay? That's going to be one of my critical values or one of my boundary points on the number line. And then over here, 2x plus 3, I'm going to have 2x equals negative 3. And then after that, I'm going to divide by 2. I'm going to have x equals negative 3 halves. Right? So x is negative 3 halves, and x is positive 2. And then I'm going to do my number line. So I do that, and then I got to plot my critical values or my boundary points. So I'm going to put like this right here, like negative 3 halves, and then, put my positive 2 over here. All right. So now what I have is what I've created is 3 intervals. And also, let me label this. So all the way out here is negative infinity. And then all the way out to the right would be positive infinity. All right. So I got 3 intervals. Interval 1, interval 2, interval 3. Now, we already put it in standard form. We already factored it. We already found our boundary points, or our critical values, right? And we know that the circles that we draw on the boundary points are going to be clear circles because this is greater than 0, right? It's greater than. It's not greater than or equal to. It's greater than. So we put that, and we put that, like that. Now, we have to figure out which intervals, boom, 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 are solutions to the inequality. All right? So what we got to do is we got to pick a value within each of the intervals. We pick a value within each of the intervals. So I'm going to start over here. So this is negative 3 halves. So to the left of negative 3 halves, and again, it's billions of choices, right? I would probably pick negative 2, though, right? Because negative 2 is, it's close to negative 3 halves, and it's, it's not that big, right? So then I go back and I say, okay, negative 2, 2 times negative 2, right, is negative 4. Negative 4 plus 3 is, well, let me do this. Let me do this. Because I want to give you like the actual value of what the binomial becomes when I plug in negative 2. 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. Then over here, negative 2 minus 2 is negative 4. When we multiply 2 negatives, we get a positive. A positive is always greater than 0. So, boom, that gives me a positive. I got a positive in this interval. So from negative 3 halves all the way to negative infinity, every value in that section, in that interval, is going to give me a positive value, right? So it's going to be a solution because we want to know what's going to be greater than 0, right? So this works. Then I want to go to the middle interval. And I'm looking for a number between negative 3 halves and positive 2. So the easiest number for me to use would be 0. And 0 is in between these, right? So I'm going to use 0. So 2 times 0 is 0. 0 plus 3 is 3. Cross that out. We already used that. And then 0 minus 2 is negative 2. So I got 3 times negative 2, which is negative 6. Negative 6 is not greater than 0. Negative 6 is not greater than 0. So that's negative. Now, then I'm going to go to this interval right here. And what I'm going to do is I'm going to pick a number in this interval. So something bigger than 2. So let's just use 3, right? Now, I'm pretty sure I know what's going to happen, right? Because usually with these problems, it goes positive, negative, positive, or negative, positive, negative, right? But let's just confirm. Let's still do the math. and let's make sure that that's going to happen. All right? Because it can't hurt, right? So we got, let me cross those out because we used those already. Let's see, 2 times 3 is 6. 6 plus 3 is 9. And then 3 minus 2 is 1. 9 times 1 is 9, and 9 is greater than 0. And lo and behold, like we thought, the pattern stands true. Positive, negative, positive. Now, we're looking for positive values. So the intervals where this, we're going to have a result that is greater than 0. So that would be this interval, right? And this interval. Now, the way we write this with interval notation, so this is the graph, right? This is the graph. All right, interval notation, we will have parentheses, negative infinity, comma, to negative 3 halves. Now, I'm using another parentheses, not a bracket. Why? Because negative 3 halves is not included. There's an open circle. Open circles match up with parentheses. And there's always going to be a parentheses next to infinity. Always. Infinity will always have a parentheses next to it. All right. Now, same thing over here. We leave this part out because this is not a solution. No value in between negative 3 halves and 2 is a solution because all of those values will give you a negative. And we're looking for values that are going to give you a positive or greater than 0. So now we go from 2, again, parentheses, because it's an open circle, to positive infinity. And you don't have to put the plus sign because when there's no plus sign, it's understood that it's positive. All right. And again, parentheses are always next to infinity. So this is one way. Oh, I forgot my U for union. So there's a union, right? So that's interval notation. But then we have like typical inequality notation, or set notation, I think is what it's called. Yeah, set notation, where we have x, comma, something like this. Yeah, I think I'm messing this up. But basically, all I'm trying to say is you'll have, let me see, x is less than negative 3 halves, or x is greater than 2. All right. So these are 3 different ways that we write the solution. All right. We use the number line, right? Right. Got the arrows on the number line. We use interval notation, right? And then we also use the more traditional inequality set notation. Okay. All right. And this right here is how you solve a quadratic inequality. All right. Please like the video, subscribe to the page, tell somebody about the video, tell somebody about the page, share the video. All right. And always remember, as usual, that there's all this math all around you. My clicker doesn't want to work anymore. I guess I gotta do this the old-fashioned way.